Everyone. GM. Okay, I think we're live now. Hey, so GM everyone, and welcome to another session of the Ethereum Nigeria weekly circuits. And this is a continuous, or should I say, a continuation of our partnership with Kernel Lab. And the main purpose of this partnership is to introduce the community to Kernel Lab and basically learn what it's all about and also build with Kernel Lab. And today we have with us Speed from Kernel Lab. He was the facilitator for the last session. And so, hi, Speed. It's nice to have you here.
Oh, hi. Yeah, I believe in your time zone it will be morning. So yeah, good morning, everyone.
Okay, good morning. What time is it on your end?
3 p.m. It's afternoon.
Okay, so good afternoon to you.
Thank you. That's lovely. I mean,
So,
yeah, thank you for having us once again. I mean, yeah, just like you said, it's gonna be the second workshop, I'll showing everyone how to technically use our product and stuff.
yeah, okay, cool. So, I think I will hand it over to you. Oh, Mr. Enoch, do you want to say something? Oh yeah, it's gone. So over to you, Speed. Take us away.
Okay, so should I share my screen now?
Yes.
Okay, 1 second. Okay, share screen. Yep. Oh, okay. Is this on?
I don't think it's not visible yet.
Um. Oh. Oh. Okay.
Yeah,
I,
it's
I
coming up.
believe it's on. Yeah. Okay. That's cool.
Yeah.
So I'll just give everyone like a small summary first on what we do because for last session, I mean it's been 2 weeks. I mean technically we're supposed to have this second session last week, but we in Thailand we have the unfortunate event. You guys probably have seen it from the news. We had the earthquake in from Myanmar, and then Bangkok also get affected as well. It's not a thing that we can control, right? Earthquake is a natural situation. But anyway, everyone at Kernel Lab are safe. Thank you everyone for for the concern as well. We are safe. So yeah, let's for the watcher out there or the viewer, someone who are watching this live streaming. So if you come to docs.kernel.xyz here, actually that is not large enough, right? Um, oh, I don't think I can zoom that. Sorry. So docs.kernel.xyz. Or another way, you can come to our website as well. And then on the top left, we have the docs button here. If you click, it will lead you to our documentation. Um, and in here, you can find pretty much all the guides of, how to use kernel, what is kernel platform, how do you use SDK and stuff. Um, but since kernel labs, we target many groups of audiences. We target kernel provider, we target smart contract developer, we target dApp developer. I mean, it depends on what are you trying to build, right? And I will actually show you guys along the way. Um, but yeah, on the left you can see we have kernel, we have smart contract, and we have dApp. Those three are actually the main category of our users. I'm not sure if I can zoom this in. Okay, let me see. Oh, why doesn't work? Oh,
Okay, I think we're just going to
okay,
follow on
okay,
our
okay.
end.
Okay, that would be nice. So I'll show you guys this page first, which is how does KOS work. So KOS, we call it KOS. It's a kernel operating system. Um, Frankly speaking, it's our marketing term because we see our whole entire architecture as as a one big ecosystem where it involves with many parts. Um, that's why our marketing team and both of our co-founders, we end up using KOS, instead of just saying like kernel ecosystem, right? KOS seems a little bit more on point. So this is what the high level of our product gonna be, right? Let's just say that we already built something that utilize our whole like protocol. So we have a dApp here. Oh, okay, I can click actually. Yeah, we have a dApp here, which is since last week, I introduced myself a little bit that I don't come from the background in computer engineering and computer science, right? So I also want to try to explain to people who are new to this game as well. So you have a dApp. What is a dApp, right? A dApp is a front end application. It's a website technically. When you go to, I don't know, like decentralized exchange
Um,
or centralized exchange, you just go to their website, right? In order to buy Bitcoin or Ether or Dogecoin, that is technically a dApp, right? You can think of it as like your website. It's a dApp. And you also have the smart contracts, right? Smart contract is a piece of code, bytecode, compiled Solidity code. We can go for like hours, right? Of like what is smart contract. Um, it's a piece of code on the blockchain network. You can call that piece of code, to do something like A plus B, A minus B, A and B, and so on, right? That is smart contract. So how our whole protocol works in a high level. So the first step would be from a dApp or from your website. Um, you could actually call our kernel node. Uh, well, I shouldn't say our here because eventually we will be open source, and also anyone can run our node. You can just take clone our code and run your own version of kernel node as well. But for now, yeah, it's only us because we are in the stage of testnet. So um, it's only us who run the node right now, and also we're still like experimenting and stuff. So yeah, from the dApp, you would have to call kernel node, and then next picture here, the kernel node will actually make a request to the whole list of predefined kernels, right? And what are kernels? Kernels are off-chain web API or functions on um, another smart contract or other like smart contracts on other blockchain networks. So just roughly speaking here, imagine that you have your main smart contract on Ethereum, right? Or even like on testnet, like on Sepolia. You have your main smart contract. Let's say you are trying to do A plus B on your main smart contract, but you don't know what is the value of A, what is the value of B that you are going to use to add it together in your main smart contract. You can actually call kernel one to get uh, the A number A, and then you can also call kernel two to get number B as well. And then after that, in your main smart contract, you can use those value to in our case, it's just plus altogether, right? That is kernel. That are kernels. um, the node will call to the list of predefined kernels, and then each kernel, every kernels will be executed in their environment, right? Because when you try to call a web API, it's roughly speaking, it's just a server, right? You call the API, the server is trying to run and do some computation over there, fetching data on the database, right? On Web 2. And then that server would just give back. It will be, executed in that environment. The node is just imagine it's the node is like the orchestrator. I'm not sure which one is actually correct. Probably orchestrator, right? And then, when all the kernels are done with their own execution, in those environments, response will be back, right? It's like when you call API on Postman, you click request, you get a response. So response will be sent back to the node, and the node will actually have to send those response to token authority. So from last week, we understand that, okay, token authority is like a policeman, right? It takes care that it will see that, okay, things go right. It should be the way I approve. So, token authority would give the thumbs up or thumbs down, right? We call that an opinion. And then token authority, send back the opinion. And now at this point, the node will be able to, no, sorry, the dApp will receive response from kernels, or we say kernel responses, and also the opinion from token authority as well. And at this point, from a dApp side, we should be able to actually make the transaction to the smart contract by attaching the kernel responses and also the opinion from token authority as well. That is what's happening like behind the scene when you use when you have like the whole application that already utilize kernel or KOS. So yeah, that is how it works in high level, right? So for now, I do have here. So we have the 10-minute tutorial page here. I understand that in reality, it's not gonna take 10 minutes, because you have to prepare your wallet, you have to prepare your funds, you have to get either scan API key. I mean, there are a lot of prerequisites, like steps, before you can actually follow this guide. But I mean, frankly speaking, like we have had this page for around like 6 months now, and what I see is that when people come into our documentation, they always like start from this page. Because initially my plan was to just keep this page for someone who just want to try it out, just want to try our product, but I have to also, I mean, we have to also accept the fact that people come in, it's a easy page, you can just come in and follow through, right? Um, but for this session specifically, I'm not gonna be, okay, guys, this is what you have to do, and then follow this page, because you can do that at your own time, right? Like, what's the point of watching this live stream if I don't actually show you something new, right? So I'm gonna come here and I'm gonna use a hard hat toolkit here. So we have the kernel toolkit, which is it's just a hard hat project and a remix project inside of this folder, right? And can I zoom this? Oh, I'm not sure why I cannot zoom. So inside of the directory of smart contracts, we have hard hat and remix. It's just a template, right? Um, and underneath here is just a template, and I think it might be better if I just show you guys one by one. So I'm just gonna clone this. I mean, if you follow along, you can come to 10-minute page, and then click option 2 hard hat on the right, and you can head to that repository. But okay, so in that case, let me prepare on my side. Wait, am I showing the? One second.
Okay,
Is
it's
it
on
is it
GitHub.
Google Chrome on the screen, or
On
oh, I
GitHub.
have to. Okay, I have to actually change it to cursor. One second, please. Okay, I might have to stop sharing this one first and then share screen. Okay. And then here. Am I sharing my screen? Oh,
Yeah, it's
okay.
coming up.
Okay, that's cool. Let me extend it a little bit. Oh, okay. This might be better. It's better with text, yeah. So what do? Right. So I have the terminal. I just use git clone, and then I'll just oops, sorry. I just copy the repository here, right? And then okay, that's pretty fast. And then let's see if we have that. So I have the kernel toolkit, and so in here you can see that we also have the some shortcut, some command line that we set it up earlier as well. We have edge, which is hard hat, just like that, and we also have command like hdvr, which it stands for hard hat deploy verify register. I mean, we try to be simple on the command line, but sometimes it's not easy to actually let's say if we use npm run deploy, and then what if we only want to deploy like only token authority, that would um, you know that would be a little bit long. um, Wait, actually I also have to fill the env file, so I'll just use this one instead. Sorry for that. So I have this project. It's with here, which is the one that I filled the env file already. I haven't done anything else. So what we need here is first thing is the Etherscan API key. I mean, if you have deployed your smart contract on Sepolia or something similar before, it would be pretty straightforward. You can just use that key that you have before, right? But if it's your first time trying to work with Sepolia or Ethereum, you might have to go to Etherscan website and get their key first. Also, we have the private key, which is a private key for this will be used to deploy the contract. When you work with smart contract, when you want to deploy the contract, you have to have the deployer, right? This is a place. So we make it in a way that you can actually use a different key for TA and the main contract as well. But it's not like always like mandatory that you have to use a two separate key. In my case, I also use the same key because I have funds and tokens in both network, and so I just use one key. And we also try to be dynamic on the kernel here, because let's just say that you are just try to experiment with our technology, right? You might have to deploy like few times, and this would be a lot easier to register through the terminal instead of the platform and stuff. Let me clear this one sec. Okay. And we also have the Infura project ID, which is for it's optional because You don't need to actually use um, inferior project ID for deploying a contract to Sepolia network, but you know, if you use the one from Infera, it's pretty fast. Me and my colleagues, we tried it like the other day. It's so different actually if you have the key. So um, let's get back to the. I'm gonna go here. So I'm gonna go to smart contracts. I can I'll list it out as well. Smart contracts here, yeah, and then in here we have our hard hat and remix IDE, right? We just use like the same repo for for people who use remix and hard hat. So if you go to hard hat and we can see we have the contracts folder here. Oh, I can make my mouse bigger. Interesting. And in here, you can see that we have the kernel, the sample, and the token authority, right? Let's focus on the token authority first because, we have been talking about this specific contract for a while. So this token authority will be deployed on Oasis Sapphire network, right? Oasis Sapphire network is the a confidential blockchain network, which means that they can. It's just like a name, right? They can keep your secret there. They say that it could actually be up to 100% confidential, and or somewhere in between, right? It depends on how you actually architect your code. Um, in here, we added like a lot of comments, like step 1, step 2, step 3. You can also follow along, right? Actually, let's just follow this along. So I have step 1. This TA contract is specifically built to be compatible with kernel ID 337. So when you try to build and use a smart contract that utilize kernel, right? You have to actually, you are the smart contract developer. You have to actually define which kernel will be run, right? You don't want to allow like the kernel that might not work with your architecture, or you might not want to pay for them because I mean, currently we are in the testnet stage. We don't have the billing mechanism in the node architecture yet, but eventually, if we go to mainnet, no, when we go to mainnet, we would have the billing mechanism, and some kernels might not be free, and you don't want to just run the one that you don't want to run, right? So you have to define that in the code here. It's actually, where is it? Okay, line 57, 58, 59. Okay, I'm gonna go down here first. 57, 58, 59. It's just set the ID, right? I could just, okay, if I just pick it randomly, maybe 1, 2, 3, something like this, yeah. That is the first step, okay. And if I go back here, step 2, the decoding bar from this DEA is for comparing response from kernel, line 106, line 108, okay. Okay, 106 right here, and 108. Oh, we can see that we have the example of kernel 337 right here, and the response type of kernel 337 is the UN256. That's interesting. So we might have to change this, right? If our response is a string or a Boolean. Um, that's interesting. We'll get to this later. And step 3, we have TA also checks node whitelist, runtime digest, line 63 and 65. So where 63 and 65? Oh, right here. So um, I mean, if we actually go through like the whole code of TA, it's I believe it's like 200 lines. Oh yeah, 300 lines now, which is kind of long, but it's also not impossible to go through like the whole TA as well. But one of the key features that we have in TA is that um, when you call to kernel node from the previous diagram that I showed you, right? Like when you make a request to the kernel node, sometimes we might have some differences in the version, right, of the kernel node that you call to. Let's say you have the node of version 5, but your TA only works with version 3. That will not work out, right? You have to either upgrade your TA to be able to accept version 5 of the node version 5, or call to the node version 3 instead on the RPC. Um, so that is the thing. But the default value right here we have, which is for node 001, which I believe we don't have to use version 003 here, okay, because from what we are going to do today, it should be able to be done with the node 001. So that is the TA. That is pretty much it for the TA. So what we have to do is, change the allow kernel ID, set up the rule if you want to compare the rule, right? And also, change the runtime digest and the node whitelist. And that is the TA. And also let's get to kernel.so in a bit. And don't worry, we will get back to TA later on as well. I mean, we're gonna go like it's not back and forth, but how do you call? We're gonna go through this, more than once. Probably that's just call it back and forth. So we have the kernel.so here. This is the part that we used to use the word kernelized, but it's not a cool way to call um, a smart contract that use kernel, right? Because at the end of the day, it's just like inheritance. Um, so technically, in kernel or so, you don't actually have to modify anything. You can just keep it just like that. But then we have the sample.sol here, sample.solidity, which is, if we see here on line number 4, we have the inheritance, from kernel.sol. You would have to import in few stuffs to be able to use the whole KOS, right? We actually have 2 example here. We have this contract of, let me, oh, that's pretty long. So we have this whole code of contract, right? And we put a lot of comments here, and it might look like it's a lot, right? But I want everyone to see our simple version of this first. Okay, let me uncomment this. So imagine that you have your existing contract, right? And would it be good? Would it be great actually if if you want to use kernel and you have to only write like 3 lines of code? Actually, let's count that, right? So uh, that's one. That's one constructor here. We have token authority public key. That's 2, right? The only authorized modifier. And oh wait, yeah, that's 3, right? That's 3. So technically, that's the three lines. Oh wait, my bad. Actually, that's 4, right? Because we have the inheritance at the top as well. So technically, you only need to change like 4 lines into your existing code, whatever you are building. Let's say you have 50 lines of code and you want to use kernel. You just put like 4 lines in, right? That's actually all for modifying any smart contract to be able to use KOS. But the earlier example here, I'm gonna comment this and uncomment this one. Oop, wrong button. Okay, but this whole thing that you can see that is pretty long and could be a little bit confusing is that I mean, if you want to use KOS, you only need to put 4 lines, right? But if you want to use KOS, but you want to actually use the kernel responses as well, this is the step that you have to do. So imagine from the earlier example that I um, give everyone that imagine you have your main smart contract that will do the addition, right? It will do A plus B, and you want to get your A value from API. You want to get your B value from some blockchain network. So you get the number value A from over there, value B from over here, and then on your main smart contract, you want to do A plus B. This is a step that you have to do, right? So imagine in our case here, we have only one kernel, right, on our example. But if you have more than one kernel, you can just do it like this, and that's the value A, that's the value B, right? That's pretty straightforward. And then, below here, you can just do, I'm going to put some pseudocode here, A plus B, just like that. If I have to, refer to the earlier metaphor. Um, that is the path that you have to do on the smart contract. So I understand that sometimes if I mean I think like specifically like if you come from background in Web 2 and in Web 2 we have so many like languages, right? We have Java, Python, um, what else? TypeScript, JavaScript, C, C++. But when you try to explore more on like this Web3 industry, you have smart contracts, which it might not be easy to read for everyone. Also, myself, I come from background in Python and Ruby. Reading smart contract, it's not like the most natural one for like humans, roughly speaking. So that is the overview, not overview. It's actually more like detailed of what you have to do in the contract, what is needed, what is not needed, right? So let's deploy one, right, and see what we have to do next. 1 second. Okay, let me save this. Did I change anything here? Oh, okay, that's fine. 1, 2, 3. I'll just save that. So, let's clear this. So how do we deploy, right, with the hard hat and everything? Um, if you haven't used hard hat before, hard hat is the JavaScript-based project that will help you deploy, test, write a script for it's actually it's kind of like Remix, right? But Remix you have UI, but hard hat you have to use command line. So typically when you try to deploy with hard hat, you would have to use npx hard hat deploy, etc., etc. That's
You don't
long,
need to
right?
compile first.
Yeah, that's right. But that's long, right? Would it be good if we just use the script from us? In the scripts folder, we also have um, a bunch of TypeScript code here. You can also go through. It's just gonna simplify the process of deploying to um, Oasis Sapphire, verifying on Saucify, deploy to Sepolia, verifying on Etherscan, and so on, right? We make a script already, so let's just use it. So first thing first, let's go to README here. So install dependencies. Let's just use npm run HH, right? HH is hard hat, just like that. Okay, let's give it a couple seconds. Okay, let's pop that down. And then after the deployment and everything, I'll show everyone our platform as well, and how to actually register stuff. So okay, that's done for the MHH. I already set up my env file here. So let's just run this command. We have deploy verify register. So let's just do it. Run hdvr. Okay. Okay, I'm gonna pull this up so that everyone can see more clearly. Okay. So what this technically do is that in a hard hat project, it would um, clean your project first because we want everyone to have a clean like setup and everything, and it will actually compile. And when hard hat project compiles like a Solidity code, it would actually compile like all the Solidity file in your directory unless you specific like one specific contract, um, and the code will actually deploy TA first to our policeman, our token authority, and then it will verify on Sourcify, and we can see the message here that I wrote. I put it as warning may appear on the terminal because sometimes some of the blockchain network is not fully supported by Hard Hat project, and also with Oasis Sapphire, even though it's EVM compatible, but it's not technically fully supported by the Hard Hat project, so the warning may appear, but it's not like an error. We can still work with that. Let's see. Okay, it's verifying, and after verifying the TA on Sourcify, um, the your main smart contract will be deployed on Sepolia network, and we will also verify that contract on Etherscan as well, and then after that we would actually register through our kernel platform, but actually in our case it will actually register for us, and ultimately at the end of the process we would have the dep id, smart contract id, that we can just like boom, just use it. So what did it say earlier? So right here, oh, as we can see, it says error. It's not an error. It says just a network problem here because Hard Hat is not fully supported by. No, Oasis Sapphire is not fully supported by Hard Hat project. So warning may appear, but it's actually already verified. We can keep the link here as well. If I copy this. Okay, we can start registering. Start registering. Okay. Okay, that's a success for smart contract. Okay, and we have some small summary here. We have the smart contract address here, which is our main smart contract, right? Or in our case, it's a sample.so. This is our main smart contract, and we have the token authority. Token authority is token authority.so, and we registered using kernel 337, which it will actually be the same one that we put here, kernel 337. And we have this smart contract ID, we have this dep ID, and we can actually get the, let me copy this. Oh, I might actually have to reshare the screen here. Okay, 1 second. Maybe this time I should do it in the whole screen. 1 second. How do I do this? Oh, okay, right here. Oop. Okay. Okay, I don't see my screen here. Okay, is my screen on? Okay, let me try to move
Oh
around.
yes, I
Is
think
it?
it's coming. Oh yes, no.
Oh, what's going on? Okay, I'm gonna stop sharing for now and then share again. Okay. Oop, share entire screen.
Hmm.
Okay,
It's
that's
happening.
interesting.
Um, hold on. Let me try and troubleshoot.
That's interesting. Mm,
It's a basic problem.
yeah. Or maybe I'll change it back to just Google Chrome for now. Okay. Not sure if this works or not. Oh, oh. Is it up as well?
Yeah, I think no, it's not up. It's
Oh,
supposed to come with come in, let me ping my team so that they can add your presentation to stage. I think
okay.
every time you present, they have to add the presentation to the stage so it will be visible.
Oh, I
So
see. Makes sense. Makes sense.
I'm trying to get to them. Yeah, perfect. So we could just like take this minute to like 5 minutes break because that is a lot.
Oh,
Okay, so I have a question. So
yeah, yeah.
the token authority is more like a template, but it can be adjusted to anything.
Yeah, exactly. I think one of our goal is eventually if we launch everything, right? If we go to mainnet and we have everything to be open source. I mean, when you open sourcing thing, you can't prevent people from building something on top of that, right? And same thing with TA. What we provide is just a template. If you want to build something, on top of that, you want to add some extra functions, it's okay. It's just that this is like our guideline. It's just that we have a guideline to actually to use KOS. You have to follow like this template. Oh, my screen is back.
Yeah, it says, yeah.
That's cool. Oop.
So there are guidelines that you actually have to follow.
Yeah. Is it echo?
Yeah, you're saying look, it's echoing from your end.
Oh, is it from my end or?
Oh no, it's I think that stopped. It says Mr. No.
Oh,
Yeah,
okay.
that
That's
stopped.
cool. Yeah. So from the terminal earlier, we had the link, right? Which oops, sorry, this one. Which shows the dep ID, smart contract address, smart contract ID. It's the same as we just deployed like 2 minutes ago. And we have entry ID here, access token here. Um, just think of it as like when you try to use Web2 service, let's say you use Google Maps or Twitter, API, right?
Yeah.
You would have to actually register on their service, register on, their backend service or something, and then they would provide the API key. API key, it's just a key that would actually, um, um, you know, they would know that your call would come from
It's
you, and then you would know that.
authorization basically.
Yeah, exactly. And we have entry ID, we have access token, just like API key. These two. will be used inside of our SDK. Um, because like earlier when we have this diagram, like from the dApp side, in order for the dApp to call to the node, and then how would the node know which list of kernel that we will run, right? If we actually the node will actually trace back from entry ID, and then trace back to where and which kernel that will have to be run. Um, so that is the entry ID access token. And we also have this one, kernel payload. I mean, because we only have one kernel in this case, that's why the platform shows only kernel 337, by the way. I'm not sure if I can zoom this. Um, I'm not sure what's wrong with my laptop here. Oh, there we go.
Yeah, zooming in.
I can zoom
Yeah.
now. Okay, that's cool. Uh, so we have 337 as the kernel, right? Um, that's why the platform shows only one parameter here. But if you have like 5 kernel, it would be like longer here. But actually, that would be more like the content for next week, right? So for now, let's just stick with 337. And we also have the SDK, right, that I mentioned earlier. So actually, I think I can show it here as well. Let me see. I mean, yesterday, this NPM website was a little bit buggy. Oh, yeah, we have the SDK here. So we have the kernel SDK that, when you try to build a dApp, you can just import it, use it as usual. And for those who are who how do I put this? Honestly, I don't like doing front end, right? I don't like doing like CSS, HTML and stuff. So I don't like doing front end that much. But we have the kernel sandbox. It's the sandbox.platform.lat. If you come here, I mean, we have the kernel flow tab that you can actually put in your smart contract address, put in your entry ID, access token. Kernel request data is actually, I can show you the example here, like kernel request data, and technically you can call a transaction on step 3 here, on the big blue button, and then you technically don't have to build your own dApp to use KOS, right? That's the thing. So one of our developers, he made this, and it's just for showing that you can call kernel by use this parameter. I understand that in the real production grade dApp, you don't technically have to define this parameters like on the UI, right? You would probably handle this like on the code level. You don't have to actually display it to the user at all, because nobody would actually be concerned. But in for our case, it's just for showing case, that you can use this. You don't have to build your own dApp and stuff. So that is the sandbox. So we have a platform, right, that I missed a little bit earlier. So this is our platform. Let me zoom in. Now I can zoom. I want to zoom everything. So so our platform right now, it's on app.platform.lat. So we have like a few tabs here on the left. And I mean, in my case, I already connect my wallet, and on the top right. But if it's your first time coming here, just connect your wallet. We don't actually collect any data on that. So technically, what is our platform, right? Our platform, it's just the place for anyone who wants to register their contract, or register their kernel. Imagine you have API somewhere, on AWS and whatever. you want to
Mm-hmm.
use your API in the blockchain transaction, right? You have to come to platform, register, say who you are, say hi, probably something like that, and um, technically, we have the registry tab here. Let me show you guys. So we have three main registries. What does this mean, right? It means that our platform, it's just a dApp. It's a dApp that we connect to the registries, right? We have kernel registry, dApp registry, smart contract registry. Like when you register on platform, it's not like you register and then we keep your data on our database. We don't have database. We don't have backend server. Your information, after you registered, it will be on the smart contract, which, in our case is the registry. Um, and what does this mean is that imagine that we have another like idea slash goal as well, is that imagine that, let's say, how do I keep this into like PG-13? Um, so imagine like tomorrow, everyone at kernel labs, like we decide to go to Bali for for just chilling, and nobody is working, right? Nobody is working at the company, and what if our website is down, right? Our platform is down. Um, Anyone out there, can just spin up their own version of the platform and connect to these registries, and they should be able um, to use KOS without any problem. So even we don't have the platform, you can still register. You can still use the technology. The technology still exists out there. So you can also go to here as well to see like the source code of the registry. We don't have like a secret or anything. Okay, let's get back to home, right?
Everything is open.
Yeah. Let's go back to home here. We have let me zoom in. Okay. Kernel, smart contracts, dApps, right? So, as I said earlier, if you go to kernel, as you can see, I have a lot of testing like kernels. If you go to register, you just have to define, do you have the on-chain function, which is the function on another blockchain network, or you have the off-chain, which is the web API, right? So for the
Okay.
on-chain, um, you can actually select. I mean, I know that for now you only have like few networks, but eventually it will open up, and you can select more. It's not that we don't support it, but we only tested like a few chains at the moment. But ultimately at the end of the day, not at the end of the day, like ultimately, we would open up, and technically you can call any chain. Um, including non-EVM as well. That's a little sneak peek, from me, and also other informations like contract address, on that chain. By the way, on that chain, function signature, function name, yeah, and and the parameter that you need. Function return type. This is important because on the smart contract, it's you have to actually use the correct type here. Otherwise, the node cannot actually call that function. But what is cool about Solidity code is that, okay, I'm going to show remix here. What is cool about Solidity code is that, let's see, which one? Even for here, I think, like right here, um, like on your, oh, can I zoom this? Oh, okay, I can zoom. Like when you have the function, and then you have the function name, or function signature, function call, function selector. We have so many ways of calling just the function, right? Uh, like we have function name, right, and then we have like modifier, identifier, and stuff. But we also have this returns, and then it will say the type inside of the bracket. which means that when you build or develop or use the existing kernel out there, it's pretty easy to actually see which type you would need for putting in here. We also have the free per query, which is as I mentioned earlier, that eventually people can monetize, right? Using kernel will be charged. It depends on how much the kernel owner would charge. It could be like $1, which is, I think that's pretty expensive. And it could be like 10 cents, 0.1 dollar. I mean, that's totally up to them, right? We also have the logos, banner and stuff here as well. That's for the on-chain, right? Off-chain, same thing. We have like logo, name, fee per query. We have the same, but for the off-chain one, it's a little bit tricky because you have to provide the Open API specification. Think of it as just a JSON that will tell you where is your API endpoint, right? It's just like that. After registration, you would get the ID, right? The kernel ID, which, earlier when we tried to deploy our smart contract and TA, we use kernel 337. If you register your own kernel, you would have to change that number into, your dedicated kernel that you want to use. And for smart contract, you have to come here, click register, just fill in the information, contract address, kernel ID, and TA. And also for DApp registration, you only need to put a DApp in. But in our case earlier, we just used one command, and then you can already come to this page, which have entry ID and access token. Everything is registered through the command line, right? But let me show you here. Oh, I'm not sharing like the whole screen, right? So but so you can imagine it in this way. You don't have to use command line. um, it's not like you use command line or you cannot use our product at all. You can imagine you use Remix, right? You can deploy your contract and everything, and then you just keep your contract addresses, TA address, and then you can also register on platform manually, just like what I just show you here as well. Like go to smart contract on the left, click register, fill in like the informations. Um, you know, we're just giving like options. You can git clone, deploy through hot hat, register um, through hot hat, or you can just come to our website, our platform website, um, and register and stuff. We're just giving options, right? It's not like only one way, only one method. And I think it's a good time here to actually mention that we will have another option as well, probably like the third option, right? The first option is like use the platform to register. Second one is probably using git clone and command, right? The third option is that we will have our command line soon. Um, Probably like in like 1 or 2 days from today, or like later this next week, because I just realized it's Saturday. Yeah. So yeah, we will have that as an option as well. For those who want to like deploy and register everything through just a terminal. That would be just another option. Um, so um, let's call this a, I believe, wait one sec. Let me pull up my note real quick. Du- 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 du. Okay. I believe that we have around 30 minutes, correct? Yeah.
Yeah.
Yeah, we have around 30 minutes. So before I talk about the bounty and grants, I'm gonna show everyone here to. I'm gonna actually make the transaction right, through our sandbox. So we just deployed and registered everything, this one, and I'll just copy entry ID. I come in the kernel sandbox here, and what did I copy? Entry ID. Okay, it's not like it's a secret or anything. It's just a hello world example for everyone, right? And then access token, and then what I need, smart contract address. Okay, then put it here. Is it correct? Okay, that's correct. And I'm gonna call execute kernels here. If I click this, you know, my dApp, or sandbox in our case, our sandbox will make a request to the node. The node will call a kernel 337, get back
Mm-hmm.
the response. The
Mm-hmm.
response will be sent to TA. TA will give the opinion back to the node, and then the node, not the node, sorry, the node will send back to the dApp. And in our kernel sandbox, you can also see the result as well, which it would show up here in a sec.
Yeah.
Okay, like right here we have kernel params, kernel responses, auth. I mean, it's not human readable at all, right? Um,
Yeah.
um, but in the production grade like app and dApp and stuff, you don't actually have to show this, right, to the users. You can just let it run like behind the scene, and um, make the transaction call by using these like values from the nodes. So but in our case, we just want to showcase everyone that this is the thing that will happen. So I'm gonna submit transaction here, and I believe, yeah, my MetaMask is popping up on here, but you probably cannot see it on the screen right now. Okay, click that, and let's wait for a bit. Let's see.
Okay.
I mean, for either scan, that would take like few seconds to do the indexing and stuff.
Okay. Still processing.
Yeah. I mean, at the same time, I can show you the contract here as well. Let's go to Etherscan. Oh, oh, okay. That's done. We have a success case on the transaction call to the new contract that we just deployed like earlier, right? So in here, we can see, from my wallet address, I called this smart contract, and if you see the code, we can know what's going on, right? But let's come here a little bit, and let me zoom in. Okay, we have the function of read message here. I can compare it with the sandbox here. We are trying to have the sandbox testing, be written on the smart contract, right? So in here, I'm gonna read message here, and we have sandbox testing. Um, like the whole architecture flow of from dApp to the kernel node to kernel back to TA to blah blah blah. It's all it's all done like behind the scene, like through like the node level data flow from A to B to C, and then we come back and we make the transaction, and we can see the result right here. Let me zoom out a little bit.
Okay.
I believe in our case, we also have the event that um, oh, okay, okay, that we also like broadcast the score, which in our case we have to change it here. Okay, the second one. So the score of my wallet address is like 100, so that's a good case. If we if I have to actually use the earlier example of like if you want like A plus B, right? A from that place, B from that place, um, you can just use it, right? Like in this example case right here, we are fetching a score, and we have the score, but we don't actually use that score to do anything on the contract, right? But we can display it, which means that if you can print it out, if you can just print F and read it out, it means that you can also use that value to do something as well. So um I believe that is pretty much it on how to actually implement kernel into the contract, right? Let's give us a little bit of the sneak peek for the next session. Is that for the next session, we will try to build our own kernel, right? And then we will
Yes.
modify we will modify this project that we clone it, and then our contract will be able to work with the new kernel that we will build. That's cool. um, so let's get back to the bounty thing that I was gonna say, right? So we
Okay.
do have the bounty, sorry, we do have the bounty program where we want to encourage people to use our technology, and also for like a new joiner to like Web3. um, Let me put up the form here. I can send this form through Telegram as well, and then you guys can probably spread it out, right? I'll send it
Yes,
after.
yes.
Yeah, I'll send it after the session. So um, we want people to try to use our technology, right? And we also want to encourage like the new joiners, like new developers. I mean, for the past few months, I think I have met a lot of new developers that they start on Web3 like directly as well. Like they don't even know how to handle with like SQL database and stuff, but they just jump to like Web3 directly. I mean, that's totally fine, right? It's not like I'm a teacher and then, oh, you shouldn't do that, John. So um, we want to encourage those groups of people as well. That's why we have this. We have a rewards of like from like 50 up until like 1,000, right? Um, for $50, it it can be for some project that is like um, you try our tech, right? You try maybe like 2 3 kernels. Maybe you just display the kernel in some way. um, you don't technically have to build like a complex computation or complex code or anything.
Okay.
But on another case, if it's like a 1,000, it should be um, I mean, I don't like to say this, but it should be some project that could potentially change the world of like Web3. You can also like mimic the existing no, not technically. You can mimic like the existing well-known like smart contracts out there as well, like from decentralized exchange or you know NFT contract. You can try to mimic that, and then utilize KOS into like that. That would be like a good showcase, right? Um, as a POC. Um, and then this form will actually ask for a YouTube link, I believe. Oh yeah. Yeah, for the YouTube link, it's okay. It's not like you have to come and speak and everything. It's just that you can do it something like, okay, click that, click this, and then see we can see that it actually works even on your machine. Yeah, I think that is pretty much pretty much it for the bounty. Am I, I mean, did I cover everything for the bounty?
I think you did. I think you did. So, I think the major thing now is actually to put everything into practice, like
Hmm.
everything you've taught today. Yeah, that's what we're looking forward to the next session. I think the next session, when is this supposed to be? Is it 22, or let me check the calendar. Let me check the time.
Yeah,
Let me check the
I think
dates.
it's the 19th, right?
19th. Oh yeah, 19th. That's like 2 weeks
19th.
from now.
Yeah,
Okay,
it's
okay,
from
that makes sense. And I think for the meantime, everybody else can join the Discord server so that they get access to testnet, and if you have any issues with your deployment, you can always reach out to Speed.
yeah, yeah.
Okay.
That's pretty lovely. Um, I mean, I believe we still have 15 minutes, right?
15.
Do we have to actually
Yeah.
like use the rest of time, or is it fine with finishing up like earlier?
Now we can finish up earlier. It's just
Okay.
I'm just checking for any questions on my end so that
Yeah,
we're not missing anything.
that's cool. Yeah,
I think that was like a lot to actually like taking all at
yeah.
once. And
Yeah.
if I understand from the explanation, when we talk about KOS, basically it's allowing you connect like external data to your smart
Hmm.
contracts. And then, oh
Yeah.
yeah, you said something about OASIS. Yes. So is that like the only supported chain? Because I on the sandbox you're showing some other network like basic poly and everything. So
Oh.
what's the whole idea around OASIS?
Yeah, so for Oasis and TA, like last year when we were trying to find like the network that TA should be deployed to, right? And we had the idea of we have to use the confidential chain. There was another network that come up as well, which is the secret network. It's the network that built with Cosmos SDK, right? And they also have the confidential confidential feature like on their network as well. But we just
Computer.
use Oasis,
Yeah.
because it's EVM, and it's just for now. It's just for now that we only support Oasis. Eventually, you know, we would support more network for the TA, and hopefully we can have TA on the Ethereum as well, so that you don't have to actually deal with like deploying on Oasis, right? Which you have to get funds, which you have to you know configure your how do you say, your smart contract development project. In our case, like hard hat, you have to modify something, in order to deploy to Oasis. But yeah, it's just for now that we support Oasis, and they have a privacy concern, which is pretty cool. It's up to like 100% confidential, which is really nice. And yeah,
Okay, so the
I
whole idea was compatibility with EVM chain.
yeah, exactly, yeah.
Okay, that makes sense. That makes sense. Okay, so I don't
That's cool.
think we have any more questions 'cause I'm checking all
Oh,
around. And okay, I think we can round up there. So
okay.
thank you everyone for staying to the end of this session. And thanks, Paige. It's always an amazing time. And I love how you explain everything down to the most minute detail. That was amazing. And
Thank you for that.
thanks everyone for staying to the end of the session. This is the end of the weekly circuits with the Ethereum Nigeria team. And you can oh yeah, Thanks to KRNL Lab for partnering with us for this session. You can join the Discord server and you can ask your questions away there. Don't forget to join the Discord server, very, very important. So
All right.
thanks.
Thank you for having me. And let's see in 2 weeks what we are gonna build together. Yeah. It will be fun.
Oh yeah, it definitely will be fun.
All right.
So
Thank you guys.
I